Yeah, that's true.
I really feel bad about wearing Quidditch wrong.
Greetings and welcome, Quidditch pronouncers. My name is Mr. Wadi. We're doing a little warm-up question here, and I've got an interesting problem. It says the Nimbus 2000 is 48 inches long, which I'm guessing is not accurate, considering, right, we see, like, that was a terrible curly brace. But, I don't know, that's just like a lumpy baby face. But anyways, clearly Harry Potter is probably taller than 4 feet, although he's magical. Maybe when he travels to this world, what if he's really short? Like, what if he's only like 3 centimeters here once he's in like the land of Hogwarts or wherever it happens to be? England, sorry, maybe. Great Britain. So if it's 48 inches long, in order to ship it, the manufacturer doesn't want a larger box than necessary. Would the broomstick fit in a box that has interior dimensions of 14 by 24 by 42? Now my students noticed 42 is shorter than 48, and sure, it wouldn't fit kind of straight across the box, but then one of them realized, wait a minute, we could store it diagonally, and then one of them realized we could even store it, I believe kitty corner was the phrase. So imagine a box. I'm going to draw one here as best I can. All right, so here's my box. It's coming together. It's like a box. It's a rectangular prism. That's the name for boxes in geometry class. So there's my box, right? So I'm actually thinking of making the broomstick go from, say, like this corner to this corner. All right, so that's the maximum distance, although we'll actually realize that it doesn't need to. So in order to figure that out, all right, I'll draw this yellow triangle. All right, in order to figure this right triangle out, first perhaps I could figure out the dimensions of this triangle. All right, which would be the diagonal of, say, like the largest rectangular face of the box, right? So, so for this triangle, let's see, we'll call this dimension 14. We'll call this the 42 and this the 24, perhaps. So to find the green hypotenuse, how could I do that? A classic Pythag. So 24 squared plus 42 squared, and then square root it. I believe I get 48.3735, okay, inches. All right, so that would be the diagonal if I was to somehow lay it flat in the bottom of the box, okay? Which, notice, answers the first question. It is large enough of a box to fit the broom because 48.3735 is larger than 48. But then the next question, what is the largest or longest broomstick that could fit into the box? And that would be this yellow hypotenuse. Now question, if this dimension is 48.3735, what's this dimension here?
14.
That's 14. So what I'd be interested in doing is some sort of Pythagorean theorem for the yellow triangle, giving me the kitty-cornered line, the longest diagonal in the box. So I would do what? 48 point blah blah squared plus 14 squared. I get 25.36, oddly enough. And then I'd root, and I get this dimension is 50.3587 inches. So you could fit a broomstick theoretically that large if it was infinitesimally thin. Obviously, you'd lose some for the width of the broomstick and whatever, but you get the idea that you could actually fit at least 50 inches of broomstick in there, right? And so that's the idea for packaging these boxes. Maybe you would want one that's, instead of long and skinny in 2 dimensions, maybe one that's a little bit more rectangular or boxish, because maybe you have to pay less shipping, you know, if it happens to fit that classification. Because I think once boxes get like past a certain length, like some unusual shape, they might charge you a bonus for that. So anyways, thanks for watching and enjoy the game, all you Quidditch lovers.